Here's a controller for this air compressor right here. And I've got power turned off to it so we can open it up. And let's just double check. All right, our meter works. Nothing here. Okay. So this is the control box for this compressor. Let me take you through it. I always try and do a quick mic CAD for something because I can't remember anything. And I usually try and leave it with whatever I built so we can look at that later. I'll take you through it real quick. All right, power's off. So incoming power is right here. It's 240 volt because we're in a residence with a neutral and ground. So 240 comes in. Well, let me give you a layout of what we have here. Essentially, we have a contactor, okay, a motor overload, just heaters and a contact block, essentially. Some distribution blocks, fuses or fuse holders, and this indicator right here. That's it. It's a very simple design. Essentially, it's just a motor control cabinet, okay, that I built myself because I had parts sitting around and it was easy to do. All right, so incoming power comes in to the line side of this contactor, okay? It comes line 1 and line 2. This is all off, remember, that's why I'm pointing, okay? Pulling off those incoming lines are a line 1 and a line 2 that come over here, and these are just distribution blocks. So we have black is L1, red is L2. The neutral incoming power comes in and goes to the neutral distribution blocks. And you can see we downsized that conductor when we came in. That's fine. We just pulled this large conductor for future use in case we ever want it here, because we had to go through, you know, drywall and such. That's our incoming right there. Okay, let's continue following. So line 1 is just distributed here. Where does it distribute? 1 goes to F1, which is fuse holder number 1. The other line goes to F3, so fuse holder number 3. So those are both L1. Red, which is L2, just goes into fuse holder number 2, F2, okay? So now we have down fused essentially a line 1 and a line 2 and another line 1, okay? So we're going to use that to control. So normally a compressor, you know, people will put like the line voltage right in this pressure switch, which is not a great idea. Especially this compressor, when I got it, already had a new motor on it that is upsized from the original. So I wanted to put a motor controller in here. So we're going to use our pressure switch really just for our control signal to fire the contactor, and then the contactor will do the heavy work of actually running the motor. So all that ampacity will go through the contactor. All right, so let's go back to this. Let's say we want to turn on the compressor. Again, power is off right now, so we can be in here safely. So coming out of F1, fuse holder number 1, we have one line 1 voltage, and it goes in here, and essentially just goes through some conduit and comes up here to the pressure switch, okay? This other conduit goes to the motor. I know it kind of looks like it goes to the pressure switch, but it goes to the motor back here. So this upper conduit, this is the pressure switch, okay? It also has the manual on off, okay? And inside here is the pressure switch, right here, okay, for the compressor. So if the pressure switch says, hey, I need to turn the compressor on, it's a continuous loop. Essentially, it's closed between two contacts. So it's 240 volts that we're sending in here. And if it needs to be turned on, the compressor wants air, 240 volts will come back, okay? So the lines that go out have this white tag on them, and then the lines that come back are right here. So just think of this as voltage going out, voltage coming back. So we said one line 1, the black, focus, goes straight there. Line 2, you can see comes out of F2, so it's fused, and it goes into this contact block, okay, on the normally closed connections. So it comes in and comes out on the normally closed. So this is essentially the heater interrupt contact block, and If there's a fault, this is gonna change state. So we would go from normally closed to normally open, or to open rather. So here this is, just think of this as always closed. It's normally closed. In the normal condition, it's closed. Voltage comes in, voltage comes out. Okay, there we go. We send our 240 volts out to the compressor and it comes back. It comes back to on these smaller wires, right? And that's going to the coil of this contactor. So it's a 240 volt coil. Boom, closes the contactor. Now we get the voltage that comes down here, comes into the overload block. Essentially, this has a series of heaters in it, and you set the correct value for the ampacity based on your motor. So there's a lookup table to do that. And if the motor, let's say, was locked, right, like locked rotor, these heaters would heat up and this contact block would trip. So that's what really makes this a motor control instead of just a contactor. It's a contactor plus these heater overloads. Right. Okay, so voltage, contactor closes, voltage comes down through here, through these big wires. You can see the black one here and the red one there. And those go out to the motor, right? They go out here, turn the motor. You'll notice that this red one comes out and goes back up, and you say that's confusing. And it comes back up onto this line of the contactor and then goes down. Why? It's because this is a three-phase contactor, okay? This is meant to have three phases going through it. We're only using single phase or split phase 240 here for this application. And top tip, you always want, if you have that, to send one of the lines back through so that all three of the lines, or let's say you had a 4-pole contactor, you want to make sure they're all used so they all wear evenly. Otherwise, you're going to have one set of contacts that are closing with no voltage and current on them, and they're going to be pristine. And the other two, or the other remainder, are going to be wearing, and they're going to wear down unevenly. So this is just sort of a best practice thing. Anyway, contactor closes, the heaters are happy, everything's fine. Boom, boom, boom. We send out our power, essentially 240 volt, but you know, with the ability of having way higher ampacity, boom, out to the motor, everybody's happy. When the pressure switch is satisfied, it breaks that contact, and that will open the coil of the contactor, stop, and we're done. That's it. Easy, easy, easy. It looks a little complicated, but it's fairly simple. Now, the rest of the wiring is really just for the indicator, okay? This light that we have here. So in the case of a fault, let's say the heater contacts open, okay? What'll happen is it's gonna change these normally open contacts, and it's gonna close them, and it's gonna take the normally closed ones and open them. We already know what these do. That'll break the voltage that goes to the coil, and the contactor will open, okay? It will stop. And then what will these do? Well, these come from that F3. So one line comes from F3 into here. This is normally open, so nothing flows in the normal condition. And then that wire goes out, it's hard to see, up here, and up to this indicator, along with the neutral, okay? So this is a 120 volt light indicator, and essentially I have it marked as overload, meaning this whole system is overloaded. There is something that has triggered the overload, okay? In that case, then the light goes on, tells the human something is going on, and obviously the contactor opens up. What else is in here? Grounding, wire management, that's it. I believe these is the instructions to set the heaters, and then again, mic CAD. It shows the same thing. That's pretty messy. But exactly, you know, it reminds me of what I did years and years and years ago. So that's how it works. I'll go ahead and energize this cabinet, and we will carefully go ahead and show you it working while it's energized.